Alright, quiet please. The second I say quiet, please raise your hand. I'm gonna teach for like 5 minutes. You think you can go on that long without attention? You be okay? Okay. So this is going back to like we skipped this because I want to make sure we finished integration and all the everything else. You kind of gotta go back to like we didn't know what integrals were at this point. So this was the idea is you're kind of introducing integrals, and you look at but we're trying to estimate the area under this curve. We've talked about this some, and so I started like I could draw these rectangles and add up the area of those rectangles, but it's not exact, right? And if I made more rectangles, would it become a better or a worse approximation? It would be better. So the more rectangles I have, you can see it kind of lines up with that space a little better. If I only had one, like that's terrible. But that'll help us like figure out what you have to know how to do a left-hand sum, a right-hand sum, and a middle, and a trapezoidal. So there's four things. There's no Simpsons. So you guys good? Can I go? Can I what? Yes. Well, are you talking about the trapezoid one? I'm going to ease your mind. Just give me a second. So the left-hand sum, there's left, right, the left-hand sum, this is broken up into two rectangles, which they'll tell you like how many rectangles break it up into. So you're going across 4 units, they said break it up into two rectangles, which means each rectangle is going to have a base of 2. If it's a left-hand sum, you look at the base of that rectangle, you go to the left-hand side and go up, and you pretend that's the height over the entire interval. So it's not ideal. If your graph is getting bigger, you're going to be like way underestimating, right? Because you're like down here, well the graph keeps going up. If the graph's getting smaller, then you take the left-hand side, then you're going to be overestimating. So that's the left, and so this is your next, like this is your block of 2. You look at the left-hand endpoint, you go up, you pretend that's the height the entire time, so this is actually a little bit of an overestimate. So that's left. Right would just flip which endpoint you use. Just talk through what's happening there. Again, we got our like width of 2 down here. This is the right rectangular method. So you go to the right-hand side, you go up, and then you pretend that was the height over that entire interval of 2. So here we're overestimating. Same thing, you got a base of 2. You pretend you go to the right-hand side, go up, and whatever that y value is, you pretend that was the y value the whole time. So that's under and over. Trapezoid, so it's not actually, I mean, it is a different shape, but you don't need to make a trapezoid. Trapezoid is the average of the left and the right. So trapezoid's usually a better one. So here's your block of 2. You go to the left-hand point, use that y value. You go to the right-hand side, use that y value, and then if you connect those, you see how it makes a trapezoid. That's really just the average of the left and the right. You never really have to worry about like the trapezoid formula. So if you take like that area and then that area and average them together, that's the same as doing that trapezoid. Midpoints is you would take the middle of your rectangle and pretend the height is based on that. Midpoint is saying, okay, I've got my block. My base of my rectangle is -1 to 1, it's 2 units wide. If I go in the middle of that and go find that y value, I'm going to pretend that's the height for the entire interval. Block of 2, width of 2, go to the middle, go up, pretend that's the height for the entire interval. They don't use this one as often, but seen it, so it's definitely on there. Say e to the x. It's not anything like new, but will a left-hand sum in this case over or underestimate? Under. Why? Because it's increasing. Pretend you can't see it. I tried to hide it, but it didn't really work. Why are there gaps? Because if it's an increasing function and you're choosing the left-hand endpoint, aren't you always choosing the lower of the numbers? So you're going to go like underneath the curve. So if I flipped it to right, what would happen? It'd be overestimate, because now you're taking like the higher of the two numbers. Mid would be like pretty decent. Mid would be pretty mid, yeah. Mid would be mid. And then trap is pretty good. I can have more trapezoids. So here's the actual answer, 18.59. Can you guys see that? 18.59. This method gives you 18.62, so it's really close. It's not perfect. It is a little bit of an overestimate because you see how that line is going over the top of the curve? When would it be an underestimate? What's true about this curve that makes a trapezoid overestimated? Yeah, it's concave up. So if this were concave down, your trapezoid would go underneath it. Does that concept make sense? Like what I'm trying to get across with the rectangles? It's on the AP test. And it is like a calculus concept, but again, I skipped it to make sure we got through integrals. So, okay. So I'm gonna do a couple runs here in a second. Get your notes out or whatever. Scrap paper, okay. Okay. Write down that table. You write down that table, Mr. Glushin? Means one spot is probably good. You said you were writing everywhere. I was just saying like one is sufficient. One location. The location can be whatever you need. Let's go.
Why is RAM capitalized? RAM controls wait.
Okay, quiet please. So this is the left rectangle approximation method. So L is your big, like that's the letter you really need. That's the left hand side. And the 6 means we're going to use 6 rectangles. So we're doing some dot graph. The base of our first rectangle would be how big? 1 unit wide. 0 to 1. So we got 6 units, 6 rectangles. So each one's going to be 1 unit, right? So the base is 1. So it's just base times height over and over and over and over again until you're done. Base times height plus base times height plus blah 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 until you finish. So the base of the first rectangle is 1. If it's the left-hand method, we are going to use the left-hand x value to determine the height. So the left-hand out of 0 and 1 isn't the left-hand value 0. So then you use the 3 for the height for that end. So use the left-hand number. Alright, I'm just going to keep going. So my next interval is from 1 to 2. What's the base of that? 1. And then if it's the left-hand method, I'm going to use the left-hand y method. So it's 1 times 5. Plus, that should be 1 time. Plus, my next base is 1. And what's the height that I'm going to use for the next one? 8. So which y value in the left-hand method will never get used? The 25 in this case, right? Will never get used. It's never on the left-hand side. So 3, 5, 8, 11, 15, and then 20. And then you would calculate that. So we're just multiplying by 1, so you just add them up, right? 3 plus 5 is 8, 16, 27, 42. So I get 62. Alright, let's do other questions on them. And then I'll round there. What about the 25? It'll never get used because it's never on the left-hand side of an interval. So what I'm going to do right hand, RRAM. So I'm going to change it though. I'm going to do RRAM 3. So that means I only want 3 rectangles. So then what's the base of each rectangle going to be? 2. Because I got 6 units wide, 3 rectangles. What's up? Well, I'm going to go 0 to 2, 2 to 4, 4 to 6. There's 7 numbers. There's only 6 units between them. So for RM3, so you got to pay attention to that number. My base, so I'm doing these are my rectangles, 2 units wide. So for my first rectangle, what's my base? 2, and then what height am I going to use? I'm going to use 8 because that's on the right hand side. And then I'm going from 2 to 4. So the base is 2. And then if I'm using the right hand endpoint, that's going to be 15, right? Plus 2 times what? 25. So 8 plus 6, 23, 4. So that should be 96. But I decrease the number of rectangles too. Which one's more accurate? The LRM 6 or RM 3? The 6 has got more rectangles. Let's do midpoints. Sorry, I guess it's like MRAM. MRAM 3. So again, I've got 6 units to cover. I'm going to cover it in 3 rectangles. So what's the base of each rectangle? It has to be 2. But you're going to use the midpoint this time instead of the left or the right. So I'm going from 0 to 2. What's the x value midpoint between 0 and 2? X value. You got to step ahead. X value is 1, so you use the y value to go through that midpoint. I asked a different question. You really wanted to make sure I didn't get it wrong. I was trying to cut my break, and you were like, no. Damn it. No. So from 2 to 4, the base is 2. What is the x value midpoint? X value?
Oh!
4 is not in the middle of anything. X value midpoint is 3, so what's the y value you're going to use? 11. Alright, Alright, if Ben doesn't get this back, so we gotta do another one. It's all up to you. What's the base? 2. What's the X value midpoint? What's the Y value midpoint? There you go. Alright, 20, 31, 36, double it, so it's 72. I want you to find trap 3. So trapezoid is the average of the left and the right. You have right 3. You do not have left 3. You have left 6. That's different. So you're gonna have to do left 3 and then average it together with R. I got 74 for the final. I thought you were running everywhere. Literally nowhere. Yeah, we part. Thanks for that. Trapezoid. Stop talking. Trapezoid is the average of right and left. Depends how many rectangles. It's the average of R, M, and L. So when I ask for trapezoid 3, I want you to find the right method with 3 rectangles, the left method with 3 rectangles, and then average them together and add up and divide by 2. Is that what you're asking me? Okay. Other questions? Yeah. Oh, like loose. Alright, let me give you another one. I want you to find those 2 things. Sad work. 0 be used twice. And 2 be used twice. Like 0, 2, 3, 4. Like you said. Were you going? It's 4. Whoa, that's the same? Very exciting. So the left and the right come out the same. Questions on this? Shh. Okay? I got a worksheet for you. I can't keep up. So everything on here is left or right. And then you got con that has the trap and the mid. You got this and con. It draws them for you. For the first one? Oh yes. Yes. This is so the rectangles don't have to have the same base. So they set it up kind of weird sometimes. Please stop talking sometimes. So they can set it up where the rectangles don't have the same base. Almost every time you're just doing like the number of rectangles they say. That's how this is. So is this left or right? This is left. So what's my first base? 1. And then what's the left hand y value? 1. So it's this base and then this left hand value. Plus, but then what's my next base? How far apart are 1 and 5? 4. I'm curious where the 3 and the 2 came from. 3? There's not a 3 on the whole freaking problem. 2. Is that why you're saying 2? Okay. Alright, well, so what's this base? 4. And then the left hand height is 0. That's why it's not drawn. Because the height is 0. Plus, and then 5 to 7, what's your base? 2. And then the left and y value, -1. And again, your next base is 2 also, and your height is -2. So this